share his idea. Welcome.
Hi everyone, my name is Chenyang and I'm from Shanghai World French Language Academy. I am currently a rising senior in my high school, and it's a great honor for me to stand here today at ICACR to give a presentation about my essay, which is the design and implementation of my handling robot based on target recognition. My presentation will be divided into 3 parts. In part 1, I will give a brief introduction of my personal background. In part 2 is mainly about the contents of my essay. I will give an introduction of my essay, and then I will talk about my algorithm, which is target recognition based on cluster analysis. After that, I will talk about hardware design and software design of my robot, and I will give a concrete conclusion at the end. Finally, I will list my references. Since I was very young, I was always passionate for robotics. In my elementary school, which is from age 7 to 11, I was involved in a competition called First LEGO League, in which our team must design, build, and program a robot using LEGO Mindstorms in a competition table-filled playing field. And at that time, I won a second-class prize in China Beijing competition. As you see, the pictures in the left is the program interfaces of LEGO Mindstorm, and the picture in the right is an example of the prototype of LEGO robot. And then in my high school, I continued to pursue my love for robotics. I was involved in a competition called the First Tech Challenge, in which our team designed, built, and programmed robots in a 10-week grace period and compete with each other. As you see, the 3 pictures in the left are the ones I built in 2017. Using them, I won the championship alliance in Shanghai Tongji University competition. And the pictures on the right are the ones I built in 2018. Using them, I won the championship captain in Shanghai American School competition. And they are all built by me by a software called Pro-E. It is a 3D modeling robot. However, a question that I asked myself after this competition is how do I implement my robot in a real-life situation? And the first thing that came into my mind is handling robot. Handling robot is a robot which follows a precise procedure to transfer the target to a predetermined position. This involves target acquisition and some algorithm. So I read some references by myself, and I came up with my own algorithm, which is a target recognition method based on cluster analysis. So traditionally, the method we use to identify projects is by shape feature method, which means we need to identify the shape of an object. However, the problem with that is the background and the shape of a project is intertwined, which means in order to identify the project, it consumes lots of CPU time and affects real-time performance of the robot. So my method, however, has an advantage that it's identified the central position and most peripheral pixels of the object at the same time, which means it saves a lot of time and increases the real-time performance of my robot. So now I will explain the details of my algorithm. So I suppose the object in my essay is a blue ball, and now there are 2 tasks to perform. The first task is to identify the project as blue, and the second task is to identify the shape as a sphere. So first of all, using the mobile phone, Xiaomi 4 mobile phone installed on my robot, I take a picture of the robot, and I divide the screen into 16 squares, each of which will process the motion of my blue ball. And using RGB calculation, which means red, green, and blue, I can identify which pixels are blue and identify the color. Then I will move the angle of my mobile phone by servos in both X and Y direction and place the ball at the center of my screen. And now, as shown in figure B and C, so now I can perform cluster analysis. I can calculate the distance between the center of a blue ball and its most peripheral pixels. If the distance is smaller than a certain threshold, I can identify the shape as a sphere. And after this step, the robot can move toward the ball and catch it up, which is the tracking process. Now I will introduce the hardware parts of my robot. There are mainly three parts. The first one is drive control unit. It consists of two expansion hubs provided by Robotics, which supports 4 motor control interfaces, 4 rotary encoder input interfaces, 6 servo control interfaces, 8 digital input interfaces, and 4 I2C bus interfaces. And then there's a visual unit. As I mentioned before, it's a camera installed on Xiaomi phone. I choose Xiaomi phone for a reason, because the performance of Xiaomi phone is better compared to Samsung and Motorola. That's why I choose Xiaomi phone. And the central unit consists of a gyroscope sensor, which is used to calibrate the position and angle displacement of my robot. The picture in the center is the structure of my robot. There's also a mechanical claw grasping mechanism, which consists of a lifting side rope, lifting plate, lifting arm seats, mechanical claw, and upper and lower link switch. There are also 4 mechanical wheels. Mechanical wheels are a special type of wheel which allows my robot to move in both X and Y direction at the same time without any kind of rotation. I chose it because it increases efficiency of the movements of my robot significantly compared to normal wheel. And now I will describe the software design of my robot. The system software includes remote app software running on a room cell phone and robot control app running on a cell phone of the robot side. Both apps are programmed with Java and are compiled and debugged in Android Studio 3.01 developed environment. The robot control app can receive the command issued by a remote app and can send the running status robot, as well as monitoring video image to the remote app as well. The pictures in the center is the same as the words. The chart on the right is the procedure of the calibration procedure of my robot. So as a first step, the hardware of the robot will be initialized and the value will be adjusted to 0. And the task we perform at this time is to locate the ball at the center of the screen. So actually, the robot itself will establish a quantitative array between the radius of the blue ball and the distance between the robot and the blue ball. The factors of the robot can be achieved by the robot itself and the initial position of the ball, as well as the values from a rotary encoder from a mechanical wheel. And as shown in the chart on the left corner side, I preset the initial position to be 5 between the blue ball and my robot. And after every 0.2 meters, the robot will have a calibration of the data and will locate the ball at the center. And the robot will approach the ball until the distance between them is 0. This flowchart is the automatic control section of my robot. The left section of this picture is the same as the last one, which is the calibration section. However, the picture on the right is what the robot do after the distance becomes 0. It will drop its mechanical claw and grab the ball so it can finish its task. Now I'll talk about the manual operation program. The current popular augmented reality platform Morpheus 7 is directly used when considering the camera monitoring function in the process of manual programming. Manual control of robot movements can be realized successfully. And then there is the universal driver of my robot. Universal driver includes hardware initializing modulus and mechanical wheel control modulus. When performing manual program, the operator sets platform toward background speed to the right or to left speed, rotation angular velocities through gaming handle, and calculates driver voltage of the DC motor using the 4-wheel driving platform by calling universal driven mechanical wheel algorithm, and controls the corresponding motor angular velocity by voltage. The code in this screen is what I write about mechanical wheel. now I'll go to give my conclusion. With the continuous increase of labor costs in modern society, there are more and more replacements of people with robots to reduce costs and improve production efficiency. The recognition-based robots I propose can achieve the functions of specified task planning and objects moving direction applications. Future work can consider more complex target recognition algorithms to achieve more complex applications, such as fruit picking and qualified product classification, so as to fully realize the replacement from to complete general repetitive tasks, thus allowing more people to engage in creative work. However, there are also lots of improvements to my robots after several testing. First of all is that my robots can only identify a sphere, which means a ball. Because if I suppose the object to be a rectangle or to be an irregular shape, I will need to write some new algorithm to identify it, and I have not yet done any testing. Second of all is that I can only identify the color as blue, red, and green, because I use RGB calculation. If the color is another color, for example purple, I don't know how to do it for now. And a problem I encounter in my testing is that if the surrounding light is very dim, I cannot successfully distinguish the color as blue or red. There are 30% of failure chance, which I'm still working on it. And finally, I find the price of my robot too expensive. As I introduced before, the hardware design and software design of my robots needs a lot of motors and a universal driver, also 2 Xiaomi phone, which is very expensive and costs for approximately 5,000 RMB. So if I really want to use this in a real life situation, I think I need to find a way to decrease the cost and make it cheaper for people. And these 5 are my references. The first one is a CCD camera. It talks about how to use it to identify a project. And the second one talks about an algorithm that to solve the contradiction between the actual performance and the efficiency of the robot, which is very helpful for me. The third one proposes a high efficiency visual system to identify moving objects. And the fourth one and fifth one are more on the application side. The fourth one, if I do not forget, is about a soccer robot, and the fifth one is about to harvest rice in a farm. So thank you. That's all of my presentation. Well, welcome to ask me any kind of questions.
How many cameras in your robots?
One. However, it can be moved by a servo in both X and Y direction.
Any questions? Okay, thank you.